Hello, welcome back to Cracking the Cryptic. Now, don't forget Gropple's Heatwave, brilliant Sudoku pack available on Patreon. So go to our Patreon site, join us on Patreon, try that pack and realize that you're very glad you did, as so many have. We're getting loads of entries. If you have sent in an entry, feel free to send it in again without spaces or punctuation. On the document which we published, that is specified, but it's not in the puzzle pack itself, and we will probably only manage to round up those entries that are sent in without the punctuation, so I'm just warning you about that. Now, don't forget our apps also available on the links under the video. That's where you can find your way to Patreon and Discord, the apps, and to all sorts of things that we have going on, and the book, which is now in a physical form somewhere in the world, which is exciting. I haven't seen a copy yet, but I'm looking forward to it. And I'm going to look at this puzzle by Eclectic Hoosier today, but first of all, I'm going to nip back to yesterday's puzzle, where I solved it with a slightly convoluted deduction to get the break in, and I asked what was better, and quite a number of you sent. Actually, there were various versions. The one I think was probably intended by the constructor, who I haven't seen comment anywhere, but I do believe this, was a set theory break-in. So it's worth noting, first of all, that none of these arrow cells could be a 6 because of the positions of 6 in the grid. But then what you have to do, let's bear that in mind. That's one thing. Now, the next thing is to highlight rows 2 and 8, columns 2 and 8, and let's highlight those in blue. And I'm also going to highlight boxes 1, 3, 7 and 9. And obviously boxes 1, 3, 7 and 9 contain 4 sets of the digits 1 to 9. Rows 2 and 8, columns 2 and 8 contain 2 sets of the digits 1 to 9. If you allow for the fact that these 4 cells that I've just highlighted are counted twice. And this is just by the normal rule of Sudoku. So what I'm now going to do, so the first thing to do is to consider an equation in which the yellow cells are the same digits as the blue cells, allowing for these 4 cells to be counted twice in blue. Now what I'm going to do is deduct from that equation any cell that can be counted only once in each of blue and yellow. And that's these. So I'm going to uncolour those. And this is a version of set theory. It's a sort of Fistmanfeld ring in a different place. Now for these 4, they're either, in the blue, they're counting blue twice. So they're 2 blue and they're 1 yellow. So if I remove 1 blue and 1 yellow from that equation, I'm left with blue. And now I have 16 blue cells highlighted and 16 yellow cells, and these have to be the same. The same digits, not just the same total, the exact same digits. Now what we worked out yesterday during the puzzle was that that is a set of 6, 7, 8 and 9. What we've just worked out is that these cells can't contain a 6. They clearly can't contain a 7, 8 or 9 as well. So where do those yellow 6, 7, 8, 9 go in blue? Not in those cells, so they must be a set in these cells. They must be a set of 6, 7, 8, 9. And once you've done that, which is quite interesting, you also know that these yellow cells that I'm now highlighting have to be the blue cells that are on the arrows. They have to be from 1, 2, 3, 4 and 5. And you can now tackle this puzzle as a kind of high-low puzzle where you're colouring the high cells, which are 6, 7, 8 and 9 only in this case, in one colour, and the low cells in another colour. And you can make significant progress. I mean, for instance, you will find out at one point, I mean, I'm not going to go into it very far, but I tried it, and I did find out that you could colour this cell as low, and therefore this pair of cells couldn't be a 1-7 pair. You know it can't be a 2-6 pair. That has to be a 3-5 pair. And I think that was the intended way into the puzzle, was to do a kind of high-low colouring exercise, you also come across the discovery that these four, in fact, maybe we can see this now. Yes, we can. Look, these four cells on that diagonal are all high numbers, 6, 7, 8, 9. Same for these four cells on that diagonal. So all these 5 cells are low numbers, and that means these 4 are the high numbers, 6, 7, 8, and 9. So this even one has to be 8, that has to be 6. There's a 7, 9 pair. You get all kinds of deductions from that stuff. And that was, I think, the intended way to solve the puzzle. Now, I'm going to accept the view of people who said that that was the intended way. I'm also going to accept the view of those people who said that that was a slightly more elegant way. That's probably true. I'm really not going to have much truck with people who said that was a quicker way, because I think that takes quite a lot of time to get through. My version broke into the puzzle pretty hard, although it was a complicated insight. But once done, the puzzle was very quick to solve, and relatively anyway. And as a competition solver, I can tell you I think quite hard about what are the quick ways to do things. And set theory is very rarely a quick way if it's an alternative. When it's the only alternative, and it's extremely powerful and indeed in that case quite quick tool. But when it's not the only alternative, I would never think of it as the quickest way to get to an answer. And I feel no shame for finding a different way in. And let's see if that happens again today. I'm going to do a puzzle called In the Spotlight by Eclectic Hoosier. Now, watch out on the rules here, because there is a completely unnecessary bit of art in the puzzle, which is the yellow circle in the center. Normal Sudoku rules apply. Digits can't repeat in cages, which sum to the given clue, normal killer. Digits on arrows sum to the digit in the connected circle, normal arrow rules. Clues outside the grid show the sum of the indicated diagonal. Normal little killer rules, those 6 cells have to add up to 33. They can contain repeated digits, so can, well, that arrow could contain a repeated digit. But you can't have repeated digits in the cages, which I think only matters for this central one. Now, this central circle, the yellow circle, is not relevant to the solve. So we may find out what it is relevant to. I mean, I have an idea. The puzzle is called In the Spotlight. I did ask last time I did a puzzle by Eclectic Hoosier. I wondered why his name was that. Somebody in the comments explained what eclectic and Hoosier meant, but I kind of knew that. I just don't know why it's a name. That's all. So anyway, he or she hasn't told us, but luckily they've sent us a new puzzle, which is far more important. So do have a try on the link under the video. I'm finally going to get started now. Let's get cracking. Okay, there's got to be a 9 in the 22 cage. Down here, though, I think columns 1 and 9 look quite interesting. Hang on. First of all, I'm going to put in 6, 7, 8, or 9 in these circles, because they're adding up 3 digits that have to be different, so the minimum is 6. Now, column 9. Right, these 4 cells, depending on whether this is a 6, 7, 8, or 9 in the circle, they add up to twice that. So they add up to 12, 14, 16, or 18. Plus the 20 is 32, 34, 36, or 38. So these two add up to 13, 11, 9, or 7, making this 3, 5, 7, can't be 9 because there's a 9 in one of those cells. And that means this can't be 9 as well. These numbers, the highest of those numbers goes with the highest of these. Yeah, I think that's right. So okay, this doesn't have a 9 in, so there's definitely a 1 on the arrow. Now, let's have a look at column 1, see if we've got the same sort of thing going on. So 20 there, plus 12, 14, 16, or 18. Now, it would be the same if this cage had a 16 in it, but this time it has a 17. So that's going to be an even digit. So I'm going to have to work these out. 12, 32. So this adds up to 13, 11, 9, or 7. Well, it can't be 7. 13, 11, or 9 leaves this being 4, 6, or 8. So we can rule 9 out of that as well, because those pairs don't, the pairs of this giving 13, sorry, what I'm trying to say is I've ruled out those two adding up to 7, so that can't be 9. Right, so this is 8, 7, or 6, so we get a 1 on that arrow as well. There's a lot of symmetry already, which I wasn't really expecting from this. Okay, what about this arrow, which is 4 cells long? These three have to be different, of course. So they add up to at least 6, plus something there that we now know isn't a 1. That's a 2 or a 3. The whole thing adds up to 8 or a 9. These three are from 1, 2, 3, and 4 and must include a 1 and a 2, I reckon. Okay, this now can't be 1, 2, 3 because of that cell. So this isn't a 6, which means that's not a 3. So 7 is definitely in one of these two cells. Okay, what is going to go in here? Let's say that was a 5 and this was a 7. So these add up to 14, 34. Okay, sorry, if it's a 5, they're 11. But we've had 7, 1, 2, 4 there. There'd have to be 3, 8 if this was a 5. If this was a 7, this is an 8, 16, 36. These add up to 9 without 7, 8, or 1 in. Oh, they could be 3, 6, or 4, 5. Oh, but they'd always use a 3 or a 4 then. In that case, the way that 8 is made up here can never be 1, 3, 4 because you couldn't fill those cells. So there's a 2 in one of those cells. Aha! And there's not a 2 here, therefore. That's my first digit in the grid. That's a 3. We now know these are 1, 2, 3 to add up to 9. That's all at their minimum now, and that's maximum. That one's obviously not 3. Is that? Oh, this now isn't a 9. So there's a 1 in this, on this arrow. There's also not, I don't know that that's 3 and 8. I have to take that out, sorry. But I do know it doesn't include a 9, because this can't be 9 and 2 with a 5 there. So 9 is here somewhere, and that's ruling 9 out of this arrow. Again, symmetrically, there must be a 1 along that arrow. So now we've got 1s locked in 4 different perimeter groups of cells. That means there's 1s in all of these 2 by 2 areas, and I don't know if I can use that. Making me think about set theory, but not every puzzle is about set theory. And as we just saw, not every puzzle is solved better with set theory, even if it can be. I don't know, I could pencil mark those with a 1, but it might get a bit cluttered. Maybe I'll just try and remember. Now, there's a 1 and a 2 in here, so it's either 1, 2, 4 or 1, 2, 5. Let's have a think about what 2 digits go in here. Oh, hang on, if that was an 8, this would be an 8, and that's nonsense. So we can actually rule that out. So one of these is a 6. Okay, but anyway, if that's a 4, this is a 6. We've got 1, 2, 3 there. These would have to add, these would be a 5 and an 8 if that was a 4. If it was a 6, we've got 7, 1, 2, 4, and these are adding to 11. And there are 3 and an 8. So there's definitely an 8 in there. Sorry, just trying to put that in. With either a 3 or a 5, that means there isn't an 8 in this 20 cage. There's definitely a 2 in this because we've removed the 8 from there. There must be a 9 down here in the 20 cage and a 9 here. There must be a 9 in that 20 cage by the same rule. Let's just keep thinking about this 20 cage. So another 11, which can't involve an 8 or a 9. So it's either 974 or 965. Don't quite know what to do with that. There's a 3 there and a 3 there, so there's a 3 in one of those 2 cells. These cells in rows 4, 5 and 6, are they the only cells where 1, 2 and 3 can go? For their boxes, these are the only 2 cells where 1, 2 and 3 can go. Oh, that's weird. Is that right? That is right, isn't it? 1, 2 and 3 are definitely a trio in the central box. Over here, 1 and 2 are on the left. 3 we've just found is in one of those 2 cells. Over here, we've done 3 and 1 and 2 are in those. Yes. Oh, well, that's really fascinating. And I don't know that I've used logic quite like this before, but look at row 4. There are only 3 cells where 1, 2 and 3 can go now. And they must therefore be 1, 2 and 3 in those cells. They must. And this one can't be 1 or 2. So that is a 3. That is really strange. I'm going to unhighlight those, but I think that's right. So these are now 1 and 2. That can't be a 4 or 5. That is 1 or 2. And we've got this 3 in the 15 cage. I don't know what you call that logic. Maybe it is just some variant of logic we use all the time, but it felt very weird. I don't know how to describe that. Right, these 2 add up to 12, so they're either 8, 4 or 5, 7. Down here we've got, that's not a 9. I should have been able to do that. This is either 976 or 958, so it forms a virtual 5-7 pair with that cell. Now, it'd be really handy to know what the possibilities were. Let's just, 8 is there. These are from, oh, 3 can't be in here because 8 can't be in here. So 3 is in one of these cells. Oh, does that mean 3 definitely is in one of those 2 cells? Is this right? Yes, of course, sorry. The whole point of getting that 3 is this is now a 1, 2, 4 set. Sorry for shouting that at me. So that makes this a 7. So this can't have 4, 8. That's a 5, 7 pair. We get 6, 8 in there. 7, 1, 2, 4. Once that's a 7, let's just check the maths. 14, 34. Those 2 add up to 11. They are a 3, 8 pair. That's what I thought. This is a 6. Yes. So now this group is 9, 5, 6. That can't be a 6. 6 up there means that can't be a 6. More weird symmetry. 1, 2, 4 there. 5, 6, 9. 6, 3, 5, 7, so 9. Have we resolved this one without me realizing it? No, I don't think so. But we've now got... No, we haven't. What has this meant that I'm not picking up? 7 there, 7 in one of those is 7. No, I'm not sure that I can see what we do next. 3, 9. Seven there, 8 there would mean 5, 2, 1. Oh, 9, 7, 4. So that would be 3, 6 if that was a 7. If it's a 5, we've got 7, 1, 2, 4. 3, 8. So there's always a 3 in this set. It's either 3, 6 or 3, 8, including a 3 now. There's a 3 here, so there's a 3 up here somewhere. So 3, 8, 7, 1, 2, 4. This could be 9, 5, 6 or 3, 6, 8, 1, 2, 5. This would be 9, 4, 7 then, which would fix that. Still don't think we can use this central killer cage or the little killer clues. They look just a bit too averagey. So what else can we do? There is, oh look, I've got a 6, 8 pair looking at that cell. There we go. Straightforward again, not picking it up. Oh, and that's not only going to fix 1, 2, 4 there, it makes this a 5. Now we're away, sorry. Bit slow on that. That's a 3, 8 pair. This is a 7. This is a 1, 2, 4 pair. Let's take out the corner marks. They're doing nothing for anyone now. And this group is a 9, 5, 6, which wasn't the more helpful one. But we've got a 5 here. So this is a 9, 7, 6 cage now. There's definitely a 6 down here. 7, 7. Right, this is an 8, 5 pair. That's looking up at this cell. That's another 7. Symmetry again. We get a 1, 2, 4 group there. This is 3 or... No, that is a naked single 5. It sees 1, 2, 4, 7, 6 in the row, 9 and 8 in the column, and 3 in the box. So that's a 5. 9 there. This is 3 or 8. What about along the bottom? 7, 1, 2, 4. That's not a 5. Is this? Yeah, this is exactly the same naked single. 1, 2, 4, 5, 7 in the row. 3, 8 in the column. It's not the same naked single. It's 6 or 9, which forms a pair with that. So 8 has to be here. That's the naked single this time. This puzzle is quite strange. Keeps doing things I'm not expecting, which is a definition of a fun puzzle, actually. We get an 8 there and an 8 here. What does that tell us here? I don't know. Now, 5, 6, 9, 8, 7 there. So these are from 1, 2, 3, 4. Oh, and look at this diagonal now. Its maximum, based on these possible digits, is 4 4s minus 1 in one of these two cells. So we can definitely fill in 4s there. This is a 4, 3 pair. We know the order. And suddenly we are getting some traction. We're left with a 1, 2 pair. Yeah, 4, 8, 11, 15. That's right. So those aren't 4s. That's not a 4. That's not a 4. 4 is here. I cannot put it in. There we go. 4 is there. 1, 2. They're not resolved, the 1, 2s. This 33 is still a bit vague, I think. Even at a maximum, 17, 19, 23. Those have to be at least 10. That's not very interesting. Oh, you keep doing something and thinking it's all falling, and it's not. Very good puzzle. 3, 8, 6, 7, 5. So 4 is in one of those. 9 is in one of those, and 1, 2 somewhere. Oh, what about... No, it's not very helpful. I hadn't really thought about this arrow at all yet. Got 1, 2 pair here, and here, and a 1, 2, 3 pair there. Ah, 4 is looking up at that. So one of those is a 4. One of these is a 4. What about this 26 cage then? I don't really know. I don't think it's clear how we fill that in. Unless, again, am I missing something? I could well be. 1, 2, they're not resolved. Everything is not resolved. Come on. What are we meant to do at this point? Let's have a look along this middle row. We've got a 1, 2, 3, triple, 4 there. This is a high number. Here, this is a high number as well. Oh, this also can't be 1, 2, 3, or 4. This could be, though, a low number, couldn't it? That is a shame. No, it can't be. There's a 1, 2 pair there. Oh, well, that's getting a bit more interesting. It can't be a 3 because one of those must be a 3 in row 5. So in the cage, we can't get a 3 here. So actually, that's quite high. Now, these must be at least 4, 5, 6, 7, which adds up to 22. So they've got to include a 4, and that's got to be here. Good Lord. These have to include a 5 and a 6, don't they? I suppose this could be 3, 2. Oh, I'm not sure now. 4, 5, 6, 7, 1, 2 is the absolute minimum here, and that would add up to 25. There's only 1 degree of freedom there. So there must be a 1 in those 2 cells. That now must be a 2, and that is quite helpful. 1, 2. That 2 is also looking down here. 1, 2. 4 is here now. 1, 2. That is where 1 goes. This is now a 3. It sees a 1 and a 2 there. And this is what I thought the puzzle might be about, given the title, 3 in the Spotlight, Losing Its Religion. There it is. And I think that was the title. Anyway, now, 4, 8. We've lost the degree of freedom, so these have to be 5, 6, and 7. Let's just check the maths again one more time. 18, 22, 25, 26. Yes. Right. That's where 9 goes in row 5. Not here. That's where 9 goes in row 6. One of those is a 7, so these aren't a 7, and that is a 7 in row 4. That's not a 6 now. This also isn't a 6, so now that's become a 5, 7 pair. That fixes this in the cage and takes 5 out of those. 5 there, 8 there. I stop there, but never mind. That's quite a lot. Now, what about this circle? It now sees 1, 2, 3, 4, 6, and 7. So it's a bit more limited. 5, 8 or 9 there with 1, 2 or 4 here. And that doesn't give me so much information. But this has got filled in. 9, 10, 15, 17. These two add up to 16. Bam, they're 9 and 7. Let me check maths. 10, 15, 17. Yes. So this is not a 9. This can't be a 1 now, because that can't be 4 or 7. It could go 2, 3, 5, 2, 6, 8. Can't go 4, 1, 5 or 4, 4, 8. So that is a 2. That's brilliant. That's a 1, 9 pair. 4 goes here. This is either 3 or 6, depending on what our sum is going to be. But that's become a 9. Sorry, I shouldn't have put a 9, 7 pair in when I had that there. 7, 1, 2. Okay, I don't know what is going on there. But this has become a 5. 7 there. Now that becomes an 8. 6. So we get a 3, 5 pair here, which is very useful into columns 1 and 9. 3, 4 here can be filled in. I think we are beginning to close in now. 1, 2 pair there. That 6, 8 pair is resolved. This is the last one in its column, so that's a 9. That's 1 or 2, so the 4 in column 8 is there. 7, 3, 8, 4, 5. Oh, I'm not quite finished yet. That is a naked single 5, is it? Yes, it is. So that's going to resolve the whole of the column. 8 there, 7 here, 3 there. I'm not making any mistakes. For some reason, something I did there felt a bit not certain, but I think that's a 9 now. 5 there, 6 and 9 can go in. That's a 6. We've got 1, 2 pairs to resolve. They're not a deadly pattern because we've got that 1 and 2. Thank the Lord. Regaining my religion at this point. And 5 and a 7 to finish off. There we go. That is a gorgeous puzzle. Thank you, Eclectic Hoosier, for sending it. I hope nobody's solving that with an assumption that that central digit is a 3, because that'll make it a bit easier, frankly. Although I thought that's where we might be going. I certainly wasn't using it for the logic, and I was entertained when we got there and found a 3 in the corner. I'll be very disappointed if Eclectic Hoosier now reveals that wasn't why it's called In the Spotlight, because of the REM song, but I think it was. Anyway, thank you so much for watching, as always. Good luck in all your Sudoku endeavors, and see you soon on the channel. Bye for now.